Animation of 2015 explosion at ExxonMobil Refinery in Torrance, California. The Torrance Refinery is a 750-acre facility located just outside of Los Angeles, California. At the time of the explosion, the refinery was owned by ExxonMobil. An important part of the refining process takes place facility fluid catalytic cracker or PCC unit. In the PCC unit, heavy hydrocarbons from crude oil are broken or cracked into smaller hydrocarbons, which can be processed into gasoline and other fuel products. The heavy hydrocarbons are first fed into a reactor where they mix with a catalyst. The heavy liquid hydrocarbons are converted into lighter hydrocarbon vapors as they travel up the reactor. At the top of the reactor, the lighter hydrocarbon vapors are separated from the catalyst. The hydrocarbon vapors then flow to the main distillation column. The catalyst falls down to the side of the reactor when it moves through a slide valves to a piece of equipment called the generator. During the reaction, a layer carbon called coke forms on the catalyst that must be removed. Inside the generator, air is added and the coke on the catalyst is burned off. The catalyst is the feedback to the reactor through a slide valve and the cycle is repeated. When the coke is burned off the catalyst, this creates product of combustion called flue gas. The flue gas flows out to the regenerator, enters the system comprised of multiple pieces of equipment, which remove any remaining catalyst particles. The generator and flue gas system comprise the air side of PCC unit. The last piece of equipment in the flue gas system is called the electrostatic precipitator of ASP. The ASP removes small catalyst particles using static electricity, while the ASP regenerates the reactor spark, which are source of ignition. It is critical that the flammable hydrocarbons in the reactor do not flow into the air side of PCC unit, as this could create an explosive atmosphere. To avoid this hazard, to those slide valves connecting the reactor and regenerator are used to maintain a catalyst barrier between the pieces of equipment. The sequence of events that eventually lead to the explosion at the refinery began on Monday, February 16, 2015, when a piece of equipment in the air side of the PCC units called to the expander vibrated forcefully. Control system automatically transitioned PCC units a standby mode known as safe park. During safe park mode, the flow of the hydrocarbons into the reactor is turned off. The flow of air into the regenerator is also stopped. The two slide valves connecting the reactor and regenerator are closed. To ensure a catalyst barrier is maintained, steam is then forced into the reactor to prevent hydrocarbon in the maintained distillation column from flowing back inside. The ASP remains energized during safe park on slide valve, however, had eroded over 6 years of operation, and indeed closed, it could not maintain a catalyst barrier in the reactor. Within 7 minutes of the unit going into safe park, all of the catalyst in the reactor flowed through the slide valve into the regenerator. A direct pathway was created by hydrocarbons to flow between the reactor and the regenerator. But the pressure of the steam flowing into the reactor as part of safe park mode was high enough to prevent hydrocarbon in main column from flowing back inside. While the unit is safe park mode, operator attempted to start the expander several times, but we were unable to do so. Refinery personnel made to definitely strategy to repair the expander and bring the PCC units back online. Operational personnel predicted the expander could not restart because catalyst had likely accumulated inside. On Tuesday, February 17th, a meeting took place involving a group of refinery personnel. The group discussed a similar expander outage that occurred, for which the refinery had developed what is called a variance. A variance is a management-approved invention from the procedure. The group decided to use the 2012 variance, which allowed a departure from the typical requirement for isolating the expander. Part of the process involved installing a blind in one of the expander out of range. On the morning of Wednesday, February 88, ExxonMobil maintenance attempted to install the blind, but they were unable to do so because steam was escaping through the open flange. Steam from the reactor had traveled through the leaking slide valve into the air side of the PCC unit. Using the variance as guide, the flow of steam into the reactor was decreased in an attempt to reduce the amount escaping from the expander, but the variance did not evaluate whether the flow with the right situation to prevent hydrocarbons from flowing into the reactor from the main distillation column, and unknown to the operators light hydrocarbon from separated unit had flowed to the leaking heat exchanger into the main column, increasing pressure inside. With the steam reduced and less pressure in the reactor, nothing could prevent the hydrocarbon from flowing back from the main distillation column. The hydrocarbons flow into the reactor, where they escape through the leaking slide valves into the air side of PCC unit. Received an alarm on his personal hydrocarbon sulfide monitor, warning him that hydrocarbons were leaking nearby. By 8:40 a.m., multiple workers around the expander received the same alarm and PCC was evacuated in an attempt to mitigate. A flammable hydrocarbon mixture was flowing through the air side of the and moving towards the exit with the multiple ignition sources. There, the flammable hydrocarbon mixture violently exploded. This is the sound of explosion. That's all. Thank you.